Hey guys, in this unit, we're going to be talking about chemical nomenclature, which is pretty much the system that chemists use to name chemicals. This process has taken centuries to form, but it's important that chemists follow the rules for naming because that way, if a new chemical is created or discovered, we know how to name it and we know how to communicate what chemicals are involved in different reactions, different labs. So this is chemical nomenclature. If you ever find yourself where you're having to name something, remember the chemical nomenclature rules and they may help you with your naming. So first of all, the first thing is that this is the first rule. If it's a pure substance, okay, if it is an element, so pure substances we know consist of elements and compounds. We have a whole rules for naming compounds, but elements themselves. So elements, even if they are polyatomic, meaning if it's O2, like the oxygen that you breathe, we don't call it dioxygen, we just call it oxygen. If there are 8 sulfur atoms together, we don't call it octasulfur for 8, we just call it sulfur. So the first rule for elements, use the name of the element even if the substance is di or polyatomic. Meaning di, meaning it just has 2, polyatomic, meaning it has 3 or more atoms. So first rule, rule number 1, if it is an element by itself, meaning it just has the O, there's no other elements with it, no hydrogen, no sodium, no chlorine, just the element by itself, use the element name. Again, compounds will vary on their naming depending if it is an ionic or a covalent bond. So now that you know the difference between ionic and covalent, we can go name some compounds. Let's talk about ions. We know that ions are atoms that have either lost or gained electrons. They do this in order to complete the octet rule, which says that we either want to have 0 electrons in the outermost shell or we want to have 8 in the outermost shell. And it depends on whatever group they are in. We've learned this. We know this. Okay, and here's all your groups again, starting with group 1. Over here with your alkali metals, group 2, alkali earth metals, and then going up to your halogens, group 7, and your noble gases, group 8. Moving on. So to achieve the octet, we know that atoms that have 4 or more electrons, they want to gain electrons to get to 8 if they have 3 or less. Oh, for example, chlorine, group 7 is going to gain 1. Chlorine is an ion with the formula Cl-1. There's 18 electrons total, but our protons are only 17, so we know our overall charge is -1. Here's another example. Oxygen is in group 6. There are 6 valence electrons in its outer shell. It needs to gain 2 to get to 8. Now it has 10 electrons total. It has 8 protons, so overall our charge is -2. Phosphorus, group 5, 5 electrons in its outer shell. It would need to gain 3 electrons to get to 8. Now it has 18 total electrons, but it's got 15 protons. Therefore, its its formula would be -3. Last one, sodium is in group 1. Its outer shell is going to lose an electron because it's going to be easier for it to lose 1 and get to 0. So now it has 10 electrons, 11 protons, so its overall charge is +1. Magnesium, group 2, 2 electrons in its outer shell have to be lost to get to 0. Now its overall charge is +2. I know that you guys know this. We've gone over this. This is ingrained in your head. But it is important for ionic compounds that you remember these charges and you remember how they get these charges, because when ions form to make compounds, their compounds have to be neutral, okay? So ionic compounds are generally formed between metals and nonmetals, okay? And we know how they get their charge, all right? We have +1 here, +2 on our alkali earth metals, 3, -3, -2, -1, and then we know our noble gases do not have a charge because their outer shells are full, and then group 4, they're just kind of weird. Okay, So what happens with this ionic compound? Here's an example of sodium and chlorine. So we have one sodium atom to one chlorine atom is going to make sodium chloride, which is a very common ionic compound, table salt. We saw that in our lab earlier this week. But I want to show you guys exactly the chemical formula for that. So what happens? All right, we've got these cations that are positively charged, anions that are negatively charged. They are actually going to bond together. Their electrical forces cause them to come together, and the electrical forces that attracts them together is what's actually holding them together. But when they come together, notice that they make a neutral compound, and we're calling it a binary compound because there are two atoms associated together. So again, here on our reactants, they are ions. We have a cation and an anion. When they combine together, they make a neutral compound. Here's an example of calcium. It's 2+ with oxygen. One oxygen is a 2-. When they combine together, they make calcium oxide. And again, that neutral compound. Now, this one's a little different. So this is potassium. Potassium we know is a 3+. It's combining with nitrogen, which we know is a 3-. So when they combine together, notice that we have this 3 that's a subscript. And over here on nitrogen, we just have one nitrogen. I want to talk about that for a second. So the reason why you have 3 potassiums to only one nitrogen is because of these charges. So if we have 3 negative charges here, we have to have 3 positive charges to equal those out. Okay, so remember, when they combine together to make that binary compound, it has to be neutral. Okay, so the way that I remember this, the way that I remember what number of a subscript to put down below is they just take the charge of the opposite atom. So here, potassium took the charge of the nitrogen, which was 3. Here, nitrogen took the charge of the potassium, which was just a +1. So we don't typically write the ones down there, but we know that it's just one atom of nitrogen. We can do another example here. So aluminum, which is 3+, sulfur, that is 2-. Notice aluminum has taken the 2 on the charge from sulfur, and sulfur has taken the 3 on the charge of aluminum. Now, in order to do that, we know, the law of conservation of matter, we can't create or destroy anything. So if we end with 2 atoms of aluminum here, we got to start with 2 atoms of aluminum here. If we end with 3 atoms of sulfur, start with 3 atoms of sulfur. We'll talk about balancing next unit. I think that's in unit 4. But what I want you guys to understand is how I'm getting these subscripts down here. So again, the rule is we just take the charge of the other atom. Okay, so now that you know how to make an ionic compound, how to balance those charges, let's talk about the rule for naming an ionic compound. Well, I'm sorry, before we do that, you need to do these practices on your own, and I will come by and check these. So make sure you have your periodic table out and you are looking at their charges. You do not have to write the full equation. I just want you to tell me what the products would be. Okay, so I'll come by and check those. Here is the rule for naming ionic compounds, all right? First, you name the cation, the positive ion. Okay, so you write that out first. Then the name of the cation, it's the same name as the metal. Okay, so if it were sodium, it would just be sodium. If it was a K for potassium, it would just be potassium. Okay, typically the name of the metal ends in ium, the suffix ium, like sodium or potassium, calcium, magnesium. Those are all examples. The name of the anion now, so we keep it the same except for we change the suffix to "ide." So we keep the root the same, the suffix changes to "ide." So for example, calcium and oxygen form calcium oxide. Aluminum and sulfur, aluminum sulfide. Okay, so here it is again. The name of the cation is the metal, it stays. The name of the non-metal, the anion, the suffix just gets changed to "ide." Okay, so pretty simple, metal plus non-metal with "ide" at the end. Okay, so some example problems. Name the ionic compounds formed from the following pairs: magnesium and nitrogen. I'm not going to go through all of these. I'm just going to do A and I guess I'll do A and B. Magnesium, nitrogen, and iodine, cadmium. Okay, so in order to do this, we've got to figure out, okay, which one is our metal, which one is our non-metal, which one would be our anion, and which one would be our cation. All right, so, and this is what this is saying here. So for our first one, magnesium nitride. All right, magnesium is going to be, our metal. Nitride is our non-metal. So this one is pretty simple. Just is going to be magnesium, because we know that's 2 plus, 3 minus. Here's what it would look like. We take the charge of the other. I'm kind of trying to skip over some of this. Oh, I guess I don't have the actual names in here, but magnesium nitride is how we would do that. The cadmium and iodine. Iodine is the non-metal. It's on the far left side of the periodic table. Cadmium is the metal. It becomes a 2 plus. Iodine becomes a 1 minus. Takes the charge. We have cadmium iodide. So, pretty simple. Now, there are some elements, some metals that can form more than one charge. And in order to specify which ion it is, you're going to place a Roman numeral that is the same, that is equal to the charge next to the cation. Okay, so iron, for example, iron sometimes is a 2 plus, sometimes is a 3 plus. In order to designate that, you just say iron 2 or iron 3, and then just put the name of the anion after that. So that one's pretty simple. Here's a chart that has some common metals that have different charges, and I'm going to give you guys this as a resource for your binder. For example, if we had tin 2 fluoride, we know that this tin takes a 2 plus charge. Fluoride is a halogen, it's in group 7, so that's going to be a 1 minus charge. So the way that would look, we would have SN for tin, F for fluorine, and again it just takes the charge of the opposite atom. I'm going to skip the rest of those. Finally, this is the last thing I'll have in this set of video notes, polyatomic ions. So polyatomic ions are atoms that have formed with multiple ions, okay? These guys have bonds that are so strong that they stick together in a structure, and that whole structure has an overall charge, okay? So these are called polyatomic. For example, CO3 has a -2 charge, and that's just called carbonate. SO4 also has a -2 charge, that's called sulfate. We name them the same way, so we'll have our cation first, our anion second, and we just keep these suffixes as ate, or ite, or whatever the suffix is. So here is another chart that has some of these polyatomic ions, and this will be included in the metals chart, so this will also be part of that, but notice they are different. So this one is a polyatomic, meaning it's got multiple atoms combined together that have an overall charge, whereas the other chart was just metals that can have multiple charges. So here's a few examples. Give the systemic names for the formulas, or the formulas for the names of the following compounds. So for A, we have FeClO4, parentheses 2, and we have sodium sulfite. So our plan, we got polyatomic ions that have an overall charge, so we're going to have to figure out what those charges are. So if you look at your chart, ClO4 is a 1 minus charge, and it's perchlorate. Iron in this case has a 2 plus charge because we have this 2 in parentheses. So in order to name this is iron 2 perchlorate. On B, sodium we know has a +1 charge. Sulfite from the chart is SO3 2 minus. So all we got to do here is combine their charges. So sodium takes the 2, sulfite takes the -1 from the sodium. And that is it. And in the next video, I will show you covalent compounds.